A high-level machine operator will produce a defective item 1% of the time. A mid-level operator has 2.5% defect rate, and new operators have a 6% defect rate. A company has 60% high-level operators, 30% mid-level operators, and 10% new operators. Find the probability that a particular defective item was produced by a new operator. So a couple of things. First of all, this looks like it's going to be really complicated, but when you start breaking it down, how many things are there in this problem? How many different things are they talking about? You see 3 different things? High level, mid-level, and new. Okay. So if you can recognize that there are 3 things, that's a big deal. Okay, because you would know there are going to be 3 things added on the bottom of that fraction. Okay, this is a Bayes theorem problem, and maybe you don't recognize that yet. Maybe this is on a test or something, and you don't know it's a Bayes theorem problem yet. But take the story problem out of it, and let's just see. High-level machine operator will produce a defective item 1% of the time. Okay, so which information do we have first? That it's defective or that it's a high level? High level is first. Okay, so I would write that down as the probability that it's defective given that it came from a high-level machine operator is 0.01. A mid-level operator has a 2.5 defect rate, so kind of the same thing. The probability that it's defective given it came from a mid-level is 0.025. And then new operators have a 6%, so we're going probability of defective given new is 0.06. Okay. Keep going. A company has 60% high-level operators, so probability of high level is 0.6, and probability of mid-level is 0.3, and probability of new is 0.1. Sometimes they won't give you that 0.1, but you can figure it out because the other 2 add up to 90%. Must be 10% for the third one. Anyway, regardless, that's what we've got. And then they're asking me to find the probability that a particular defective item was produced by a new operator. So think about which of those 2 pieces of information you have first. Okay, we want to find the probability that it's defective given that it was from a new operator. Wait, no, that's backwards. We will find the probability it came from a new operator, given that we already knew it was defective. And again, here's kind of your hint. When you see that you're looking for n given d, but they had already talked about d given n, when you've got the reversed conditional probability, that's where you would know, oh, this is going to be Bayes. This is that formula. This is that formula for Bayes. So let's look at this. Probability of n given d equals, and there's going to be a really big fraction. Okay, so draw a really big fraction bar here. Now we know it's part over total because it's probability. It's part over total because it's probability. So look back at your formula and think about that pattern. Okay. The pattern for the numerator is we want the probability of the first letter n times the probability of the reversed conditional. Once you nail down that pattern, it's pretty simple. That's the numerator. Now the denominator, you're going to take that pattern and you're going to put it for each of the 3 things in this problem. So one of them is going to be an exact match of the numerator. But then think about what else we have in this problem. If it's not new, it could be a mid-level. So probability of mid-level times, keep the same pattern, probability of defective given mid-level. Plus think about the only other thing in this problem is high level. I should have put an L right there, but whatever. Probability of high level. And then probability of defective given high level. That's your part over total. Part over total, that's Bayes' theorem. So go through and fill in the numbers where they go. Probability of nu is 0.1, so we can put a 0.1 there and there. Probability of defective given nu was 0.06, so we can put that there and there. You're always going to have one of them match the top and bottom. Just one, though. Probability of mid-level was 0.3. Probability of defective given mid-level was 0.025. Probability of high level was 0.01. Probability of defective, well, that's not right. Probability of high level was 0.6. Probability of defective given high level was 0.01. Sorry about that. Okay. So really, it's just a matter of calculating all of that. You've got 0.1 times 0.06 over 0.1 times 0.06 plus 0.3 times 0.025 plus 0.6 times 0.01. So get you a calculator, and we know 0.1 times 0.06. That would be my numerator. And then on the bottom, 0.1 times 0.06 plus 0.3 times 0.025 plus 0.6 times 0.01, 0.0195. No. So then divide that. And you get about 0.3077. Probability of nu given defective is about 31%.